Hey everyone, and welcome. So today, we're going to crack open the core ideas behind one of the most popular programming languages on the planet, Java. We're going to simplify the big concepts and see what makes it tick.
Have you ever stopped to wonder how in the world the same app can run on your Android phone and your laptop and your smart TV, maybe even your car's navigation system? I mean, they're all completely different machines. It's a huge puzzle, and it's the exact problem Java was born to solve. And this is its famous promise: write once, run anywhere. You might hear people call it WRA for short. It's this incredibly bold, ambitious goal that honestly became the secret to Java's unbelievable success. But how does it actually work? All right, so here's our game plan. First, we'll dig into that run anywhere promise. Then, we'll uncover the secret sauce behind it all, the JVM and something called bytecode. After that, we'll look at why Java was built to be easy to learn, explore its other superpowers, and finally wrap up with why it's still such a huge deal today. You know, before Java came along, life for developers was, well, it was a massive headache. If you wrote a program for Windows, you had to completely rewrite it to get it to work on a Mac, and then you'd have to do it all over again for a Linux machine. It was a total nightmare, super inefficient, and just ate up so much time. Java's goal was to put an end to all that. Okay, so that leads us to the core question. How did Java pull off this magic trick? How did it let you run the exact same code everywhere without all those painful rewrites? The answer is this really brilliant two-part system. Right, so how does it actually do it? How does one single piece of code get understood by so many totally different types of computers? Well, it's all about a clever three-step process.
It's kind of like a three-step dance. First, a developer writes their code in a standard .java file. But here's the key. When they compile it, it doesn't turn into code for a Windows PC or a Mac. Nope. Instead, it becomes this special intermediate thing called bytecode. And that right there, that's where the real magic happens. So what is this bytecode stuff anyway? Think of it like a universal language for programs, almost like a programming Esperanto. It's not speaking Windows, and it's not speaking Mac. It's just a pure, neutral set of instructions that isn't tied to any specific kind of computer. Okay, so if bytecode is the universal language, then the Java Virtual Machine, or JVM, is its personal universal translator. Every single device, your Windows computer, your MacBook, that Linux server, has its own custom-built JVM. And that JVM has one job: take that universal bytecode and translate it right there on the spot into the specific instructions that that particular machine can understand and run. And this, right here, is what was so revolutionary. With older languages like C++, you had to go through the whole compilation process for every single platform, a Windows version, a Linux version, and so on. But with Java, you compile it just one time into that universal bytecode. And then you can take that single file and run it on any machine that has a JVM. That is the write once, run anywhere promise in action. It was a game changer. All right, let's switch gears a bit. Beyond just being able to run anywhere, Java was also designed from the ground up to be simple, to be easier for developers to learn and use, especially when you compare it to the really complex languages that came before it. But simple can mean a lot of things, right? In Java's case, it wasn't about being basic or dumbing things down. It was about being smart, about building a language that was more robust and less likely to fall into common, really frustrating programming traps. And this philosophy is just perfect. A huge part of Java's simplicity comes not from the cool features it has, but from the complicated, messy, error-prone features it chose to leave out. It was a deliberate act of subtraction, of filtering out the junk to keep the language cleaner and more reliable. For starters, it got rid of something called pointers. Now, these give programmers direct access to a computer's memory, which sounds powerful, but it was also a massive source of bugs and security holes. Java said, nope, not going to do that. It also removed other confusing features. And maybe most importantly, it gave developers automatic garbage collection. This means programmers didn't have to manually manage the computer's memory anymore, which, let me tell you, was a huge cause of program crashes back in the day. So you take all of that, and what you get is a language that's not just easy to use and portable, it's also incredibly powerful for building the kind of big, robust, serious applications that pretty much run our world today. Let's look at a few of its other superpowers.
First up, it's object-oriented. Now, that sounds complicated, but all it really means is that everything in the code is organized into these neat, self-contained objects. Think of it like building with Lego bricks. You can build complex things, and you can reuse the bricks over and over again. It makes managing big projects so much easier. Then there's security, which is a huge deal. Remember that JVM, that virtual machine? Well, because the Java code is running inside that protective bubble, it's walled off from the computer's core system. It prevents direct access to memory, which automatically eliminates a whole category of nasty security problems. That's why it's so trusted for building secure systems. And then we have something called multithreading. This is just a fancy way of saying a program can do multiple things at the exact same time. This is absolutely critical for modern apps. It's the difference between a smooth, responsive experience and getting that annoying spinning wheel of death while it tries to do something in the background. Yeah, a really easy way to picture this is to think of an app that can have several conversations at once. It can be downloading a huge file in one thread, playing some music in another, and still instantly respond to your mouse clicks in a third, all at the same time without missing a beat. That's the power of multithreading. So when you step back and look at the whole picture, when you put all these pieces together, the run-anywhere portability, the simplicity, the built-in security, and these powerful features, you really start to see why Java hasn't just survived for all these years, but actually thrived. And this table really just ties it all together beautifully. Every single one of Java's core design ideas leads directly to a massive real-world benefit. Platform independent? That means it runs on any device. Simple? That means faster development with fewer bugs. Secure? It helps build virus-free systems you can trust. Multi-threaded? It gives us the smooth, responsive apps we all expect today. And the results of all this smart thinking? Well, it's estimated that Java now runs on over 3 billion devices around the world. That number is just staggering, and it's a testament to the power of solving a really fundamental problem with a truly elegant solution. And really, that's the whole story. From its write once, run anywhere philosophy to its focus on simplicity and security, Java's core ideas fundamentally changed how we build software. So I'll leave you with this final thought. Now that you know its foundation and why it was built this way, what would you build with it? Thanks so much for watching.